This is the Intro to Statistics Exam 1 review, page 5. So we are going to start with problem number 8, question number 8, which has the data for fasting blood sugar levels for a sample of 12 patients. We want to display this in a stem and leaf plot. So we've got fasting blood sugar levels. And the first thing I'm going to do, let's see, it looks like I go from the 70s to the 130s. So my stem is going to be tens, 70, there's 80, 90, 100, 110, 120, 130. And now I'm going to list the ones over here. So I've got 76. There's my 76. 114, I got 114, goes right here. 82, 97, 77, 130, 79, 98, 86, 97, 91, and 92. So 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And remember that as we do these stem and leaves, we want the leaves in numerical order. So I'm going to repeat my stem, my tens. 7, I got 76, 77, 79, 82 and 86. Let's see, 90, 91, 92, 97, 97, 98. Nothing in the hundreds. I've got 114. Nothing in the 120s. And then 130. So for number 9, I'm going to do this by hand here. I'm going to start by reorganizing the data. If you would like to do this in Excel, that is fine. Please let me know if you have any issues or if you are not getting the same values that I am getting here. So 30, 31, there were 2 33s. 34. I do always go back and double check after I list to make sure I have not missed anything. So I will compare the numbers I have in the original set. Let's see, 46, 56, 75. Cram that one in there. Okay. So our range is our largest value minus our smallest value. When I subtract that, I get a range of 59. First quartile, median, and third quartile, I am going to start with the median. And let's see, I did count earlier, 1, 2, 3, 4, 5. So my n here is 19. I have 19 values, which means if I split this evenly, 19 divided by 2 is 9.5. So I should have 9 on each side and the median in the middle. So 1, 2, 3, 5, 6, 7, 8, 9. Puts my median right here at 34. And then 1, 2, 3, 4, 5, 6, 7, 8, 9 after. So I know that 34 splits our values in half. So now I have 9 data values in the bottom half of my set and 9 values in the top half. If I want the first quartile, I want the median of the bottom half. So 1, 2, 3, 4. It is going to be this fifth term. I get 28 there. And I am going to do the same with the top half. 1, 2, 3, 4. I get this 42. Notice this has divided my set into 4 groups that have 4 data values in each group. Okay. My interquartile range, Q3 minus Q1, I get a 42 minus 28, which gives me an interquartile range of 14. If I am using my upper and lower fence to determine if there is an outlier, I have to calculate those. The lower fence is the first quartile minus 1.5 times that interquartile range, which is 28, minus 1.5 times my 14, 28 minus 21, which is 7. I have a lower fence of 7. My upper fence is going to be Q3 plus 1.5 times that interquartile range. Let's see, 42. The one mistake that students tend to make more than anything else is to use the same quartile value when we calculate the lower fence and the upper fence. And notice we're not doing that. We've got 2 different values. We use Q1 to find our lower fence. We use Q3 to find our upper fence. So 75 is an outlier because it lies above the upper fence. Why is it important to obtain a randomized sample when we do research? We do that so we know the data that we are collecting and that's our sample, right? We want to make sure that is representative of the population. And question 11. A local politician won 64% of the vote in a special election, claims to have strong support from the population, but only 11% of eligible voters voted in the election. What type of bias is involved? This is definitely non-response bias. Right? Because 89% of the eligible voters didn't even vote. And I'm going to say did not vote / respond, hence the non-response.